Turbo Repo is porting from Go to Rust, our strategy for making updates and maintaining stability while we migrate languages. Okay, we've read something earlier this year that was about how they ported Turbo, and now they're doing this whole Turbo Repo business. So let's see this. All right, we should recognize some of these people here. Let's go. In a previous blog post, the one we've already read, right, we talked about why we are porting Turbo. Remember, it was like Rust makes developers happy. When you have happy developers, they tend to work better, blah, 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 blah. The high-performance build system of JavaScript and TypeScript from Go to Rust. Now we're going to talk about how. It's pretty exciting. Let's see the how. Let's see the nitty-gritty. Today, our porting effort is in full swing, moving more and more code to Rust, but when we were starting out, we had to make sure that porting was feasible for us to accomplish. A migration from one language to another is no small task, and there's a lot of research to do upfront to ensure that the end goal is attainable. Yes. Here's how we started the process, validating our current porting strategy and made the call to port Turbo Repo to Rust. I think that anything that involves a bunch of system calls, I go on the fence of whether you should stick with Rust or stick with Go or go to Rust. Honestly, I think there's a lot of value in Go in this, and I don't think Go and Rust you're going to experience a huge slowdown or difference. In fact, I think writing in Rust, you might even find yourself slowing down because you're just not good at writing it, right? I am very curious which is better, right? Port versus full rewrite. When we were planning our migration, we briefly considered a full ground-up rewrite, but talking the idea through, we realized it wouldn't fit our goals as well as an incremental port would. What is an incremental port? Incremental porting moves code piece by piece, running new and old code together at the same time. Roman writing, pretty much. The goal for the chunk of code being moved is to keep the behavior exactly the same as before it was ported. Yep, you're just going piece by piece. There's like the first block is the hardest block because it has to do like the core work. And then you slowly start unraveling that. You know what I mean? In our case, this means we need to have our Go code and Rust code interoperating with each other. We want to do simple translation, explicitly avoiding making improvements or changing functionality while we're swapping out the languages for the slice of code. That way, we can do an intensive testing against both sets of code and complete the migration as quickly as possible. Why we didn't do a full rewrite? Full rewrites are very tempting. They are so tempting, and they seem like the best plan every single time. They are more simple to write and ship, as you don't need to worry about the before and after code working together. You also get a clean slate to write new and improved version without the warts and technical debt of the previous iteration. However, full rewrites also come with some serious downsides. Agreed. Completely agreed. This is a great chart, honestly, is that this is what your code did look like. This is what it looks like now, and you fundamentally changed pieces. So it's like really hard to go one-to-one on how it's going to operate and everything. First, a full rewrite tends to require a complete halt to shipping new features. Otherwise, you run the risk of chasing a moving target as the old code base grows while you catch up with your new code. Full rewrite also does not guarantee a better user experience. Often a rewrite ends up less than seamless, and it's not feasible for the new version to match the old one. Feature for feature, edge case for edge case, the surface area of the rewrite grows. There's more room for error, and as the users can end up frustrated with the breaking changes and missing features. Good reason not to do full rewrites. I'm always very skeptical of full rewrites. Full rewrites are almost always a mistake. Almost. Full rewrites also require building an entirely new code base, which is a large quantity of unused code. In our experience, unused code, even when verified with tests, can be a breeding ground for bugs. We wanted to make sure that any new Rust code was properly exercised as we moved through the porting effort. This is good. Just delete all the old project. Remember the mistakes you didn't go and rewrite in Rust. We choose to port. Therefore, we decided to port Turbo Repo to Rust instead of doing a full rewrite. The porting did necessitate some trade-offs, so we had to introduce a significant amount of complexity into our code base so that we could interop between Go and Rust. This complexity meant slower developer velocity to start with, but we look forward to workflow improvements going forward, particularly when our porting effort has finished. More importantly, we know we could continue shipping features to Turbo Repo users while porting. All things considered, we determined that this was a reasonable compromise and a path we would take. Perfect. I think this is really good, honestly. I think this is a really good reason to do that. Starting the port. Rewrite Rust and Go, please. Yeah, just switch it up. Just rewrite it. Just rewrite it already. We've already heard this song. All right, we choose to start by writing a small new Turbo Repo feature in Rust. This way we could add new functionality from the roadmap for our users, integrating Rust into the build process and interacting with the existing code as little as possible to reduce our initial complexity. Once we laid the groundwork, we knew that we could slowly port more and more code to Rust over time. Global Turbo. we decided to have our first Rust feature be Global Turbo, a feature that allows users to install Turbo Repo as globally available command on their machine. Okay, a global installation of Turbo will look for a locally installed Turbo program in the suppository, execute it if it exists, or otherwise fall back to a Global Turbo binary. That way, you can easily run Turbo from anywhere in your suppository and also keep a specific version of Turbo pinned to your package JSON. This is great. This is a perfect way to do things. Beautiful. Beautiful. Let's see. C apps, web, Turbo app, infer Turbo, no local found, run. Beautiful. This feature is implemented through what we called the Rust shim, a bit of Rust code that wraps the existing Go code. The Go portion is compiled via CGo as a C static library and then linked to the Rust binary. Luckily, Global Turbo only requires a few features from the rest of Turbo Repo's code, such as reading configuration and navigating the file system. Okay. Why not Turbo in Turbo Pascal, though? It would have been the best. This is where it gets fucky. Okay. CLI parsing. As we implemented Global Turbo, we realized we needed to parse a few command line arguments, like current working directory, the argument for setting Turbo's current working directory. Well, clap. Come on, get clapped, kid. After Global Turbo, it made sense to continue by porting the rest of the CLI argument parser to Rust. To parse arguments, we used clap. Let's go. Clap. Clap's the best. Rust equivalent to the NPM package of an NPM package. It's just so good, though. Clap lets you define a data type with the arguments, annotate a little bit of it, and automatically create a parser. Let's go. With the pieces in place, we had to work on sending the args from Rust entry point to the Go code. For better or worse, C is the standard foreign function interface, FFI. Let's see. So we had to use C communicate between Rust and Go. What do you mean you had to use C? You had to write C for this? You couldn't just directly call if you're doing a static linked library? I thought you were doing like a C build of the Go. I'm confused. Do they actually write C? Do they have like a bit of C in betwixt? Go isn't C ABI compatible? I don't know. Is it? I thought it was because Rust is C ABI compatible. There's like a little flag repr C or something like that you can put on the top. Rust C Go. C, the great equalizer, makes everybody cry and segmentation fault. We wanted to avoid having too many types in C, as we weren't confident that we could write cross-platform C types that played well with both Rust and Go. Instead, we decided to serialize our arguments to JSON and send them to Go as a string. Even though JSON serialization does have some overhead, we knew these argument structs would only be a few hundred bytes in size, so the performance would be minimal. Yeah, that's fine. I'm surprised, when I hear this, I'm actually surprised they didn't just run the Go program as a submodule and then allow standard in and just like write to standard in, like do some basic IPC or something like that. On Rust side, we used another cornerstone of the Rust ecosystem, Saturday, which allows you to, by the way, that's properly how I didn't know if you know that, but to say Saturday correctly, you have to say it like that. Anyone that tries to give you some other way, they're lying to you, okay? It's Saturday. And Jay Diesel would have solved this because Tom's a genius, let's just face it, which lets you serialize and deserialize data in various formats. Using some minimal annotation for the Go side, we were already using a JSON in the code base, so it was easy to receive the JSON string and deserialize it into a Go struct. Well, plus Go supports the JSON at a first-class citizen, though heterogeneous lists are a bit odd. Ship it. Pull the something. I said pull the plug. That usually means to kill it, so that didn't make any sense. By the way, sorry for this light part. I'm reworking the lights. That's why I look a little green right now. With these two features ported, we are ready to ship our first hybrid Go release. However, before we could release, we needed to make sure the Go Rust binary worked in all the various contexts that Turbo repos used, like different operating systems and Linux distros that we supported. As we tested our code, we started noticing some issues on a couple platforms. Windows difficulties. You know, the easiest way to get around Windows difficulties is just don't support Windows. Honestly, boom, first try. Classic Windows issues, EBN. EBN every time. I swear. It is just the worst. On Windows, there are two main toolchains, Microsoft's Visual C++, MSVC, and Minimalist GNU for Windows, MinGUI. Go only uses MinGUI, but we're using Rust with MSVC. Oh gosh, this caused some runtime issues, but luckily the solution was simple. We moved Rust toolchain to MinGUI. Next up, we had some issues with paths. Windows has a couple concepts of paths, including what's called a universal naming convention, YUNC path. Oh, really, that's funny. Windows has a couple concepts. One of them is called universal naming convention. Is that not working or something for everybody? Is it not quite universal as promised? When you ask Windows to canonicalize a path, resolving all symlinks and normalized components in the past, it gives you a UNC path. However, despite its name, UNC paths are not supported everywhere. Classic Windows W. Oh my goodness, this is just like Windows to a T. What's that? That's a GUID. Where's it supported? On Windows. Nobody else uses it. Everyone uses UUID. We do global unique identifiers around here. What's that? Universal naming conventions. Who uses it? Windows does. Universally available in Windows. Sometimes not even Windows itself. Oh, yes. Not even Windows uses it. This caused a few bugs where we provided a UNC path to get an invalid path error. The solution was to use helpful Rust script called dunce that lets you canonicalize a path and get non-UNC path back, handling the intricacies of this problem for us. Let's go. Alpine Linux. The second set of challenges came with Alpine Linux, the one where you hate your life. At Vercel, we use Alpine, a common operating system for cloud computing to create lightweight containers for building your projects. Yeah, it's fun until you have to use it. Alpine, though, does not come with glibc, the de facto implementation of the C standard library. This is a problem because many binaries assume glibc is installed and don't package it themselves. There are some libraries that pave over this issue by using packages like gcompat or libc6compat, but they didn't end up working for us because the version of glibc that Rust requires was too modern for our supported targets. When we tried to run the binary, we'd get errors that required glibc. Classic. This is like such a classic. As a result, we decided to compile Turbo Repo as a fully static binary. This meant we packaged our own C standard library implementation using Muscle. You can't statically link glibc due to licensing issue. Beautiful. Licensing. Isn't licensing just the best? Isn't just licensing just the best? Like, to me, if this is a thing that's available, it just seems like your licensing sucks. This seems to work just fine for both Rust and Go. Is it because glibc is like under the license that requires you to also do the same licensing for your project? Isn't that like the required? Well, not all open source is open source. You know what I mean? Some open source is like a cancer and it spreads wild and fast, whereas others aren't like that, right? And so this one is more like a virus type acting where it's like, if you use me, then you must be the same version of library we use, right? And so it spreads. It's like RxJS. It spreads to the whole code base. This seems to work just fine for both Rust and Go. Rust lets you set the C standard library in the target, okay, versus this. And Go does not use a C standard library by default. However, when we ran the statically linked binary, it would return a segmentation fault. Got him. Even worse, when we inspect it with the debugger, we find a corrupted stack. And even worse, the seg fault appeared to be coming from Go runtime itself. This makes me so sad to hear. All right, after a lot of searching, we tracked down to a 7-year-old GitHub issue, which explained that Go cannot be compiled as a C static library with Muscle. This posed a significant challenge as Alpine Linux is essentially an essential platform for Turbo Repo and its users. We had to go back to the drawing board and figure out how we could ship our Go Rust combination. Eventually, after a ton of deliberation, we came up with a solution. We'd compile our Go code and our Rust code as two separate binaries. The Rust code would call the Go code and pass the args serialized to JSON via the CLI. I feel like, did I not say a little IPC? Did I not say a little in and out, give it the old in and out? It called it. It's not terrible. It's actually not a bad idea, okay? I know this may seem hard, but honestly, when you're doing Roman writing like this, where you're kind of writing two different environments, just make it simple. Do the thing, because you know that one part of this is going to go away forever. You know what I mean? We knew that the args were small enough that they could be passed via CLI without too much of the performance hit. And because we were using a serialization format, the code changes were extremely small. All we had to do was change how Rust was sending the JSON string to Go. With that, we were able to get our first hybrid Go Rust release out the door. The first version of Turbo was shipped to you using these compilation strategy, version 170. What we learned, through this effort, we learned a lot about moving from one language to another. Let's take note of what we found. Serialization is useful for FFI. Our first takeaway is that serialization formats are very useful for interoperability. By serializing to JSON, a format with robust support in both Go and Rust, we were able to minimize our FFI surface area and avoid having a whole class of cross-platform issues. So one thing I would have done differently than they did is I would not have used JSON. I would have used something like protobufs. And the reason why I would have used protobufs is that protobufs would have provided a universal serialization format and deserializer. And so you kind of get one place to define your types, and then your types are defined for both programs. You don't have any of this like moving target type nonsense. Like, you know what I mean? That's just something that I'm like fully on board with, is always, if you have two different platforms you're using, use a common type definition. You know what I mean? The moving target issue, yeah. Exactly. Cross-language bugs. When we had to switch from single linked binary to two binaries, we were able to do so with relative ease because of our FFI surface area was so small. Okay, I would say that I don't know if I agree with this because I haven't done enough FFI to have a strong opinion about it, but it seems like you were doomed before you started. And I think you had some odd FFI stuff because you were dipping into C to call from Rust to Go. I feel like something was wrong there, just like... in general, I'm not really sure what was happening, but the engineers at Vercel are very, very smart, so I'm just going to assume whatever was the reasoning, it was the correct reason, right? Protobufs worked fine between Rust and Go. Exactly. The trade-off here is that serialization and deserialization is slow. You can only depend on this technique if either you know your serialized payloads will be small or you don't care about the performance hit to your use case. Yeah. Porting takes preparation. The second takeaway is that incremental porting is feasible but requires a lot of careful testing and strategizing. Agreed. We ran into quite a few tricky bugs, and we caught these issues through a lot of automated and manual testing. Right here. Okay, check out their testing. Testing is also extremely important for nailing down the behavior of your code, whether it's an exact edge case of CLI parsing or the order in which configuration is loaded. These exact details are not so crucial when you're writing your first implementation, but they're absolutely paramount to avoid breaking changes during port or rewrite. You should aim to write tests before you start porting your code, so you have a known specifications to work against. Okay, so I would say this is the one time where I would agree with like tests before code, and the reason why I say that is because you already have a working version, right? You've already figured it out. And so to me, this makes more sense, but I would... No, actually, I disagree with it. Now that I'm arguing this to myself out loud, I can already feel myself disagreeing with this already, which is that the reason why I don't agree with this is that when you're rewriting in a different language, your structure and how you're doing it is so much different. And what you don't want to do is mirror your current code base into a new language. You want to write it with the idioms, the canonicalization of that language, not the language you're using. And so if you try to write your test beforehand, you may go in with the Go knowledge of doing things versus going in with the Rust knowledge. So I feel like I feel like you should have a set of what's it called? You should effectively have a set of integration end-to-end tests that you can prove work, and then your tests are already written for this new one, right? So it's already existing. That's my personal feeling, right? You wouldn't want to test against the units level, more like the end-to-end level. If you don't embrace the language features, why the hell are you using rewriting anyways? Exactly. So it's not really TDD at that point. All right, cross-compatibility is difficult. The third takeaway is that cross-platform, cross-language release engineering is extremely challenging. This is why I think a lot of people default to interpreted languages. Every platform, language, and compiler. That's also why people love Go. They love Go because it just seems to work everywhere. It's one of the most... This is why Go is just such a popular language, is that it just works everywhere nicely. Every platform, language, and compiler has their own quirks that makes interoperability difficult, and more things you have working together, the more opportunities you have for new complications. Porting is worth it for us. Finally, while porting from Go to Rust has been challenging, it has been proven correct choice for us strategically. Even with our porting effort going on, we've been able to ship new features, handle bugs in our existing functionality, and help keeping our users... and keep helping our users while we migrate. It requires some extraordinary, tricky debugging, careful planning, and rigorous testing, but we believe that it has been worth it. Try ported Turbo Repo. Turbo Repo. Whoa. Turbo Repo saved this many hours of time for the product engineers and CI machines at Vercel. Nice. That's a lot of hours. That's a lot of hours. Even if it only equates to 5 seconds per build, like when you have a build that goes from 3 seconds to 10 seconds, like there is this point in time that's like I just accidentally went on Twitter time. You know what I mean? There's the I accidentally went on Twitter time, and that happens at like what, 15 seconds? Right? So I totally am like, I'm totally on board for the faster it gets. Oh, Anthony Shu is here to answer articles about this. Oh, Anthony, I didn't realize you're here. I'm going to keep spamming it. Well, awesome. I like to hear that. It's 10 seconds for a user to switch tasks. Yeah, you got to be very careful. Well, hey, Anthony, I didn't even realize. Yeah, stay tuned for the next article. Rewriting Turbo Repo and CSS. Now, that's the article we want, Anthony. That's the article. This is great. Mastodon. Oh, gosh. No. This is not even a part of it. I need another Mastodon server because apparently having interviewed at the NSA 13 years ago when I was an undergraduate means I'm banned from programming languages server. Fediverse, are you okay? People use Mastodon. Twitter's just ran by a bunch of power-hungry billionaires. Mastodon. Also, you. Just like, okay. What kind of bargain are you getting at? Why? Why? Oh. I love Reddit mods. If I could have anything in my life, it would be Reddit mods running my social media site. Like, that's what I've always wanted in life. You should read the image. You can no longer use your account, and your profile and other data are no longer accessible. You can still log in to request a backup of your data until the data is fully removed in about 30 days. We will retain some basic data to prevent you from evading the suspension. Don't work for the NSA. Do not work for the fucking NSA. Do not interview for the NSA. Do not entertain the possibility of working for the NSA. I thought you were cool, ! I saw you on PL Twitter and thought you were a neat person. Why would you work for the effing NSA? Again, why would you want a Reddit mod controlling your social media site? Just let you know, why would you want that? Every time I think Twitter couldn't get any worse, I literally read this and go, oh yeah, Twitter's pretty freaking awesome.